Hello, my name is Andreas Himmler. I'm Senior Product Manager at dSpace. So we showcase at the European Microwave Week this year a lot of tools that are required and used for developing and testing radar sensors, the software and the hardware from early development stages up to end-of-line testing. And at first I would like to take you on a tour around the booth to show you what we have here this year. So this is a software that is used for software-in-the-loop and hardware-in-the-loop testing. It simulates the behavior of a radar sensor in a real environment, so it has a very detailed, high-fidelity simulation of the environment. It also has a very detailed, high-fidelity simulation of how the radar works. We will have a look at this in a few minutes after we have took the tour around the booth. So let's move forward to the next demo station that we have here. The next demo station here showcases a radar target simulator that we have. In this case, this radar target simulator has our very latest new radar front ends for 60 gigahertz applications. 60 gigahertz become to be used for in-cabin applications, to detect what happens within the car, to do life sign detections. And this is what we showcase here, the 60 gigahertz front ends. And what we do is that we mimic with this device, with the target simulator, we mimic vital signs, so heart breaths, how the chest moves, and the radar detects the heartbeat of the passenger that it seems to see. This is shown here, and we will have a look at this also in a minute. The next demo station that we have here moves beyond the development stage. It's validation of advanced driver assistance systems and autonomous driving. This system that you see down here is a radar test bench. It is used to test radars in test scenarios where cars drive around. And so you see the radar under test here. It's an EuMW radar in this case, and these rings, they typically move. They contain transmit and receive antennas. They generate radar targets to mimic for the radar, for simulation purposes, the environment, to test whether all the functionalities of the radar and let's say automatic brake assists, functionalities like these, whether they work as it is intended. The next step is around the corner here. The next step is for end-of-line testing of radar sensors at the Tier 1. So it is used for production testing, final test before the radar sensors leave the factory, and that includes calibration. This system is very different to other systems as it has a very short distance between the target simulator and the radar under test, which can be seen if you look here in the window. What you see over there in the light gray area, there is hidden from where we are the horn antenna that generates the target. Down there, we can have a look at that from another window that is in here. There is the radar under test held by a robot. And up there in the ceiling of this chamber is a mirror that reflects the radar waves from the antenna down to the system under test. And this setup enables to have far field distances in this very compact chamber. This would otherwise, for very modern radar, require very huge test systems, 7 meters long, 8 meters long, about that, because these radar systems, they need to see far field conditions when they are tested. So this is what we have here. We have developed this together with another company, the company Norths. They do these end-of-line test systems. dSpace is doing the radar target simulator and has done a lot of work for making this work with regard to the RF. And we have a very special way to measure the alignment of the overall setup. That means, is the mirror perfectly aligned to the radar under test and to the target simulator? This is also proprietary for dSpace, because we make use of very special things that are in our target simulators. This is a quick walk around the booth, and my colleagues will now take over to show a little bit more details about what we have at the different stations here. Thank you very much.